Okay, let's give you guys some more practice. So find the limit of this sequence as n tends to infinity. So press pause and have a go. Okay, so to do this, there are at least two ways of doing it. The first way is to let set y to be this thing here. We are trying to eliminate this, but let y be this thing here. So now natural log both sides. When you natural log this will then come down. That will then give you this, and then you've got your natural log here, and then this complicated thing, this complicated thing. So from here you would then rewrite as this. So here you've got one block multiplying another block. So this is a fraction here. So this gets multiplied to the top, giving you this. So now as n tends to infinity, you can see that this thing here is heading towards infinity. Well, negative infinity, and then this thing here is heading towards infinity. Negative infinity over infinity. It is in a way of this form here. So this is an indeterminate form, which means we can apply L'Hopital's rule. So applying L'Hopital's rule, differentiate this, that will then give you this whole thing here. I'm going to assume that you know how to differentiate this. So if you differentiate this whole thing here, then, well, imagine, if you differentiate this, imagine it to be like this. Plus 4 to the power of n. So when you differentiate it, it would be 1 over the bubble, which is this thing here. And then you've got to times the derivative of the bubble itself. The derivative of this bubble itself is this thing here. Okay, and then don't forget your negative here. Carry the negative down. Well, differentiate this. It will then give you this thing here, and then differentiate this. That will then give you this one here. So you're dividing by 1, so we can pretty much ignore this. This thing here gets multiplied to the top, giving you this. So this thing here gets multiplied to the top. That's the bit here, and then this thing here is this thing here, and then your negative and your negative. Well, if you tidy this thing up, it will give you this thing. So now from here, divide top and bottom by the higher of the two. So divide top and bottom by 4 to the power of n. Divide the bottom by 4 to the power of n. So that means this thing divided by 4 to the power of n, that will then give you this. This thing divided by 4 to the power of n, that will then give you this thing. This thing here, this is actually 2 to the power of n divided by, well, this thing divided by 4 to the power of n will give you this. This divided by 4 to the power of n is 1. So now as n tends to infinity, you can see that, don't forget, the natural log of 2 is a constant. This is going to be much, much bigger than this. So this is going to head towards 0. Exactly the same divided by exactly the same. That's going to give you a constant natural log of 4. Natural log of 4. This thing here is going to go to 0. This thing here is going to be 1. So you're going to get natural log of 4, which is this thing here. This thing here, and then you've got over 1. So as n tends to infinity, it will head towards, this whole thing here will head towards natural log of 4, and then you've got your negative here. So as n tends to infinity, this whole thing here will head towards this. Okay, and then now exponentiate both sides. So e equally to both sides. That will then give you this. Don't forget, this is a constant here. This is just a number. So now whenever you have a power of a negative, you can rewrite it as 1 over the positive version. Well, from here, that will then take you to here. So and these two in a way cancel each other out, giving you a 4. So the answer here is a quarter. Okay, the other method, which I prefer, is much nicer. We're trying to find the limit of this. So this is a second method now. We are trying to find the limit of this. This is to the, you've got something to the power of minus. So that means you can jump to 1 over that something to the positive. So this is negative here. So you can, well, yeah, you can rewrite this as this. So now looking at this, the trick is to factorize this. If you factorize this, well, take the 4 to the power of n. So let's just look at this bit. So this bit is this bit here. But let's just concentrate on this bit here. So what I mean by factorize the 4 to the power of n is this. Currently you've got this 2 to the power of n plus 4 to the power of n. Well, rewrite this whole thing here as this 4 to the power of n. This is just a trick to solve this. So rewrite as this. So now if you get this times this and this times this, it will give you this. So rewrite this as this thing here, So now you've got 1 to the power of 1 over n to the power of 1 over n. So now from here visualize as one block multiplying another block to the power of another thing. So whenever you have a, b to the power of c, you can do this, c times 1 here. So it's really a to the power of c, b to the power of c. So this times this n here is 1. So that's this block here, and then you've got this whole block here. So this times 1. Imagine this as being to the power of 1. So this times this will be to the power of this. So basically, hang on. So basically, you've got one block here and one block here. So now, and then up here, visualize this one block times another block here. So now this times this will give you this block here, and then this. Well, imagine there to be a 1 here. This times this here will give you this whole thing here. Okay, I hope you can follow that. So here you've got one block and another block here like this. Well, think about it. From here, that would take you to here, and then now as n tends to infinity. So you've got a number that's less than 1, and then if you keep on multiplying, well, this is going to head towards 0. We've seen this in the past, and then you've got 1 here. 1 to the power of this is going to be 1. This whole thing here is going to head towards 1, and then you've got 1 over 4. So the limit is 1 over